looking ahead, test is Tuesday. We'll review Monday. So today's the last day of new stuff. And there's not really a whole bunch of new stuff. We're just going to put a little bit of what we know in a different format. So it's a little bit new, but mostly old stuff. And then you'll have all of Monday to review. Test is Tuesday. You know that you have the review worksheet already. So if you want to start working on that, answers are posted. You could get all the studying done or none of the studying done. Obviously, that's kind of up to you as to when, whatever works best for your schedule. Just don't forget there's a test coming next week on Tuesday. All right, today's notes are fill in the blank. So I will need to remember to post that for you people watching online. It'll be posted by the time you see this, though. This may look a little overwhelming. The good news is we're not going to fill out all of it today. In fact, we'll start to fill out more of it next week when it says develop the unit circle, practice the unit circle. That's when we'll get more into this. But today we're going to mainly just be concerned with the angles on the unit circle. Let's back up just a second. It's called the unit circle. Yeah, who would have guessed with that huge title at the top? Because it's the 1 unit circle. 1 unit meaning the radius is equal to 1. And maybe that seems unimportant or not a big deal, but later that's going to be a big deal. The radius is 1 is going to help you on a lot of these blanks. A lot of the blanks we're not really getting to today. So radius is 1.
Wait, so that means all these radiuses are 1?
Yes, it means all of those radii are 1.
So we can just kind of put that.
It's centered at the origin, so that doesn't really show up there because there's enough blanks on there, but it's like the XY plane is laying on top of this, and right there in the middle is the origin of the XY plane. But again, if we put that on there, that would be, it's already borderline too much, so no more than what we got. All right, the only blanks we're going to look at today are the inside blanks, the angles. We'll worry about what the outside blanks mean later. Let's just worry about the inside blanks. So we've briefly mentioned this before, but we always start measuring, or we start our angles from the positive x-axis and measure up from there. So that's 0. Let's see, there's lots of different ways to fill this in. What's all the way around? So what do you think the blank is right underneath it? 360.
That means the other side is 180.
That means the other half is 180. Yeah, you're starting to throw them out. The
90 at the top.
90 at the top.
That's 270.
270 at the bottom.
What's half of that?
And what's half of? Don't grab a calculator for half of 90.
No, I was doing the other ones.
45. Okay, half of the other ones maybe I would grant you. Let's don't worry about the ones in between yet. Let's just hit the 45s. So 45, 90,
I'm still trying to.
135. So we're adding 45 each time.
225. That's the one I was trying to calculate.
225 plus 45 more gets us to 270. Plus 45 more is 315.
What's the top left one?
Plus 45 more is 360. So if we add, what's that? An eighth of a rotation all the way around. That's 45 degrees. That would fill out the 45-degree markers. Now, do you have a guess based on what it looks like and some previous geometry knowledge as to what you think this and these two angles might be?
15 under and 15 over.
Yeah, it's 30-60, right? Because key triangles from geometry were 45-45-90 and 30-60-90, and we'll use those later. We're not really doing those today, but that's the motivation for including those on the unit circle. Rather than half of 45 is 22.5, but that doesn't make an interesting triangle. The 30-60-90 does. So now you could fill in counting by 30. So like this much of an opening is 30. So if you ignore the 45s, I don't have enough popsicle sticks. Wait, yes, I do have enough popsicle sticks. If you ignore the 45s and count your way around 30 degrees at a time, you can fill in all the rest of them. So 30, 60, 90, 120, 150. And we have some already there, so that's sort of a check that we're doing this right. So 180 matches up. 210, 240, 270, that's right, that's good. Keep going. Yeah, I mean, you'll know if you messed up, because if you don't land back at 360, then something went wrong. So every 30 degrees gets a mark, and every 45 degrees gets a mark. I mean, we absolutely blitzed through that, but you guys were racing ahead of me. You were going even faster than I was, many of you. Questions on any of those?
Are the blanks next to them for the radians?
The blanks next to them are for the radians. Let's slow down a little bit here. Let's race ahead if you want, I guess, but let's do the easy ones first. 0 degrees is how many radians? 0. So yes, the inside circles are the degrees, the outside blanks are the radians. Let's actually go in the same order. So what's all the way around in radians? 2 pi. And so we'll be able to figure out some of these. What's halfway around?
1 pi.
1 pi.
Pi.
Halfway between 0 and pi is pi over 2, and you can use that blank as the fraction bar if you like. And then in the bottom, halfway between 1 and 2
3 pi over 2.
is 1.5 or 3 pi over 2. And again, I think it's convenient to use the fraction or use the blank as the fraction bar. Okay, that wasn't too bad. Let's back up and think about the 45. Well, what's halfway between 0 and a half?
Pi over 4.
Pi over 4. Right? Half of a half is a fourth. So halfway between 0 and pi over 4, or halfway between 0 and pi over 2 is pi over 4. So let's look at the sort of the 45 markers, the middle markers, the middle quadrant markers. We're counting by pi over 4. So be careful on this one. We're adding pi over 4, we get to pi over 4. We add another pi over 4, that makes 2 pi over 4. Is my finger pointing at 2 pi over 4? Is 2 pi over 4 the same thing as pi over 2? Yeah. If we add another pi over 4,
3 pi over 4.
we're at 3 pi over 4. If we add another pi over 4, how many pi over 4s is that? 4 pi over 4,
1 pi.
also known as 1 pi. So we're still tracking along here. If I add another pi over 4, that's 5 pi over 4. If I add another pi over 4, that's 6 pi over 4. But I already have 3 pi over 2 written there. Are those the same thing? Yeah, it's reduced. Okay, well, now back up because I want to get to this one. So 5 pi over 4, 6 pi over 4, 7 pi over 4. And then 8 pi over 4, also known as 2 pi. So filling in the unit circle angles is really not that bad, especially if you do all of them at once, because it sort of self-checks. Right? If you land at 11 pi over 4 over here, then something went wrong somewhere. All right, 30 degrees. This one's a little bit trickier maybe. How about we just off to the side convert that somewhere? No, because it's not halfway. Let's do the conversion, the train track conversion here. So 30 degrees, 180 degrees is pi. So 30 over 180 reduces to pi over 6. So 30 degrees is pi over 6. Now, there's two methods we can do to start filling in the rest of them. You're welcome to do either one. I'm only going to do the easier way. You can go to each spot and do that conversion thing. So you can do 60 times pi over 80, then 120 times pi over 180, then 150 times pi over 180. And there's nothing wrong with that. You'll get there. What I would rather do is do it like we did when we were counting by 30s, 30, 60, 90, except now we're counting by pi over 6s. It's a little bit harder than counting by 30s. I'll grant you that. So this is 1 pi over 6. Here we go again, ignoring our... I want to ignore the over 4s. We only want to look at the 30 degree markers here. So that maybe that helps me only see the 30 degrees. So this is 1 pi over 6. If I go another pi over 6, it's 2 over 6, but that reduces to pi over 3. There's going to be lots of reducing along this way. So we have to be careful. And then I start talking to intentionally make you lose track of where we were. And then we got to start over. So this was 1 over 6, 2 over 6, 3 over 6?
Yes.
Yeah, that's right. 4 over 6,
So
2 over 3. But don't forget we're counting by over 6s. So that was 4 over 6. So this one is 5 over 6. Does that reduce? No. 6 over 6. Feel good about 6 over 6. That reduces. Then 7 over 6. That doesn't reduce. So that was a couple of easy ones. 8 over 6. 8 over 6. Which would be 4 pi over 3. Oh, I lost track. Let me back up. 7 over 6, 8 over 6, 9 over 6? Yeah, that's the same as 9 over 6. 10 over 6. 10 over 6 is 5 over 3. That was 10 over 6. 11 over 6. And then here we go. Did we do this correctly?
Yeah.
12 over 6 is 2. So I feel pretty good about those. So we just filled in the unit circle with radians and degrees. Now, there's a few other things we need to be careful about. Let's find the quadrant of 20, you know what, go ahead. Find the quadrant of 23 pi over 6. Well, there's a couple ways to do this problem. Well, first of all, I guess, what do you recognize, or what's weird about this problem? What makes this problem?
It's almost 24.
It's almost 24. So it's more than one time around, right?
It's almost 2 times.
12 over 6 is one time around.
It's almost 2 times.
It's almost 2 times around. That's not the way I'm going to work this problem, but that's a good way to work it. If it's almost 2 times around, what quadrant is it going to be in?
It's going to be 4.
4. Nothing wrong with working it that way. Not everybody sees it that way. I'm going to find a coterminal angle. Because it doesn't always, if you recognize it, great. But you're not always going to be able to recognize where it
The
is.
screen is in the way.
So let's,
Your
my face is in the way, is what you're trying to say. So let's subtract 2 pi. Because that will get us a coterminal angle. Now, subtracting fractions, common denominator. This kind of helps. We counted around in 6s, so we remember that 2 pi is 12 pi over 6. So 23 minus 12 is 11 pi over 6. And sure enough, as some of you were right on from the get-go, that's in quadrant 4.
Oh, that's 11.
Now, if you could see right away that, wait a minute, that's almost 2 times around. It's quadrant 4. That's fine. If you need to do some work, that's okay too. Nothing wrong with that.
So we don't have to show work if we got that right away.
You don't.
Okay.
I will try to ask you some that
Don't show.
forces you to show work. Like this one.
Let's see if I can work.
I know, you take it as a challenge, and that's fine.
Can we do this on the back?
Yeah, you could do this on the back. But I like to be able to see my unit circle there. Let's find the quadrant of negative 17 pi over 3.
Alright, bet.
Okay, what's the negative mean in terms of like if we're trying to find it on the
We need to
picture?
Flip the quadrants.
It means we'd be going backwards.
Yeah.
Find the quadrant of negative 17 pi over 3. But I don't want to go backwards 17 pi over 3. Like that's more than one time around and you're going backwards. So what could I do to find a coterminal angle? I could minus 2 pi,
It's going to be on top.
and that would make things worse.
It'll be quadrant 1.
So what else could I do? I could add 2 pi. That would be a better thing to do. Minus 2 pi wouldn't be wrong, it just wouldn't be helpful.
Is 2 pi.
How do I add 2 pi if I want it to be over 3? I'm out of space, so I'm trying to...
6 pi over 3.
6 pi over 3. So that would be negative 11 pi over 3. Which still is like, So what do you want to do next?
I'm guessing.
Let's add again.
Oh,
Right? We can add 2 pi as many times as we like. Negative 5 pi over 3. Now, some people can find negative 5 pi over 3. They can figure out what quadrant that's in.
You can just
reversed.
But it's backwards, so it's quadrant 1.
A.
If you don't like going backwards, you can always avoid going backwards. If the negative thing is bothering you, then what could I do to
Quadrants and say you need to switch it back.
make this a positive angle?
Add 6.
Add 2 pi one more time. And I get pi over 3.
But you still have to now get put backwards.
I don't have to go backwards anymore because now I have a positive angle. So if you don't like going backwards, again, some people get comfortable with this and they can go backwards pi over 3 or 5 pi over 3 and they're fine. Other people, they never get used to going backwards. They're just going to add 2 pi until it turns positive and then they don't have to worry about it. And there's nothing wrong with that. So, wait, pi over 3 isn't my answer. Find the quadrant. Well, now it's pretty clear that pi over 3 is in quadrant 1. So you could convert them to degrees and then figure it out, and then minus 360. But you've added an extra step when you've done that. On the other hand, you're working in degrees rather than radians. So I get it, and that's not wrong.
If it was this way, it'd be right here. Negative.
In fact, I'm out of room. So I'm flipping it over. Some of you flipped it over already. Find the quadrant of 247 degrees. Degrees, so we don't have to worry about the radian stuff. 247, where is that? That's exactly the right question. So we flip it over, and you don't have to be perfect. You just got to get the right quadrant. 247 is in there somewhere. Definitely in quadrant 3.
Can you use test questions like that?
There are a few test questions like that.
Can a bonus be like that?
No.
A 10-point bonus?
How about negative 913?
15-point curve.
This would be one where some people would back up
Hold up.
and try to do it in their head, and that's fine.
Hold up.
I don't want to mess with that. I want to add 360
360.
so that I don't mess it up trying to do it in my head.
720.
Speaking of doing it in my head, let's see. 913 minus 360. 3, 5, 5. Negative 553. Again, some people are going to be like, oh, I can figure out where that
Is
is.
this with or without calculator?
Others of us are going to say, let's keep adding 360. $193, or negative 193.
Here, so it's in quadrant 4.
Negative 193, some people can get that. I can back up a little more than 180.
Cool.
And I don't land in quadrant 4.
Shoot, what is negative?
Yeah, the negative just means I go backwards. And I land in
It's quadrant 3.
quadrant 2.
2.
Again, if you don't like going backwards, and some of you won't, you'll add until you get a positive, and that's fine. 360 minus 193 is 167, which is in quadrant 2. So,
I just did the fraction thing where I just flipped the things.
negative 192 or 167, either way,
167.
you land in quadrant 2.
So it doesn't affect the negative, right?
The negative affects which way you go.
Where you go, but it doesn't affect like one thing there, you go the other way.
All right, that's it for today. Okay? So it's just getting familiar with unit circle, angles and degrees and radians. The worksheet will ask you to graph some things, but you kind of have the picture of what to graph. So,
So now
Not-
we need to put a curved like edge, not like where the radian is squared.
As
at,
long as
we
it's
need to
in
have a
that
curve.
quadrant, I think he's cool with it. Like, at least it's in the box.
And the
as
quadrant-
long as you get the quadrant right,
Yeah,
you'll be fine.
Like for these, it's not a right triangle. It's a big. That's not
Correct. Later, we will draw some right triangles on here and do some other stuff, but that's the unit circle is so complicated, we try to chop it up and take it kind of a day at a time. So this is day 1. There's a lot going on, and there's a whole lot more going on that we're not going to worry about today.
The question is, when